Welcome back to our series where we were looking at pharmacovigilance and Python. And right now we go straight ahead into machine learning models. So if this is your first time, please check on the playlist just to get acquainted with where we were. And if you are continuing with the series, well, that's good because now we're diving into machine learning models, and we'll be starting with the basic ones, the logistics and linear regression models. Okay, so make sure to like, comment, and also subscribe. It goes a long way for the YouTube algorithm. Okay, so without wasting any more time, we had seen how to prepare our side effect reviews data for our modeling task. So we wanted to model if or how side effects reviews can be classified. Either is it severe, not severe, mild, and those kind of stuff. So that was like our objective in this case, right? So just to get that footing and that foundation of what do models actually do, we will begin with logistics and linear regression. All right. So in this case, we will be using a logistic regression, but I'll just want to begin with linear regression, help us understand what a linear regression is, and then what a logistic regression is, because these are the foundation of machine learning models. So a linear regression is like the simplest, most fundamental machine learning algorithm. And our task normally is to find the best fitting straight line in a hyperplane or some high dimension that fits our data. So think about this. Think about like you want to predict a patient's blood pressure. So in this case, you have values in ages, weights, maybe even height that you use now to predict blood pressure. So these values will be in numbers, will be like 0. The output of the blood pressure will be 140, 120, 130. So if I'm talking about systolic, and maybe the diastolic of 80, 90. So you see, those are continuous variables, right? So you want to estimate what those values are based on features like age, weight, height, and so on. So for logistic regression, we normally use a simple linear algebra equation. So again, this video is just meant to give you that high overview of what it entails, so that if you want to dive deep, we can maybe dive deep into subsequent videos. So in this case, at its core, the linear regression equation is y is equals to mx plus b. You probably have come across this in even high school, where m was the slope, x was the x-axis, obviously, plus b, which was the bias or the error, the bias, and then y is what you're predicting. Similarly here, but with a bit of caveat. And the caveat here comes in, as you'll see, the W replacing the M with W. But we'll touch on that. So in our case, the Y value still represents what we want to predict. So in this case, drug rating, maybe you want to predict the blood pressure reading for your patient. X1, X2 are our input features. Okay, so in our particular case, we are more focused on word frequency reviews. Then W1, W2, now this is what we call the weights in which the model learns based on our feature. So normally, when you want to predict something, you have features, but all these features don't contribute equally to your output. So what happens is that the model normally assigns weights to your features and gives the most important feature the highest weight, so that every time that feature occurs over there, the model adjusts its weights so that you can be able to have a good prediction model. As simple as that. And now the bias, this bias term I want to introduce is called bias or intercept, is the baseline prediction on all inputs are 0. The bias term helps the model to generalize better when it doesn't have it gets access to unseen data. So the bias here, simple as that, helps the model to generalize better when you have unseen data. So you don't want your bias term to be 0, because that means that the model will learn everything. So when I give my model this data, the model will learn everything in this data. So when I give it new data, it won't be able to learn or to predict based on the new data because it has just mastered how one training data looks like. So in this case, bias term helps with overfitting, but we'll dive to that later on. Okay. Next concept I want to introduce. So the first concept we have covered, y is equals to mx plus b, and we have seen how it is expounded here to y w1 x1 plus w2 x2 all the way to wn xn plus b. So n here is until the maximum values that you have within your set. Then over here we have something important, the cost function. So we've looked at the equation, we looked at the weight, now we go to the cost function. The cost function now is what your model learns, okay? So in this case, our cost function in this linear regression will use what we call a mean squared error. What this simply takes is the average squared difference between its predictions and the true values. So the reason we square is because we want really to punish the outliers, so that the model really punishes the outliers, and we want also to get rid of the negative differences so that we can. It makes the mathematics a bit easier, and it makes our model to be clean in some sense. All right. So we won't again dive deep into the equation over here, but the most important takeaway is to understand there's something called the cost function. Okay. So different models will have different cost function, or we can use different cost function depending on the task that we want to learn, or we want our model to learn. Okay. So the other thing now is in order for the model to minimize this cost function, because at the end of the day, that's what we'll be doing. The model learns by minimizing the cost function. The model wants to go over or iterate over the training data and be able to minimize this cost function to be as close to the true value as possible. So this will be, we'll talk about this evaluation metrics such as accuracy and what so, but in essence, the model wants to reduce this cost function. And in order for it to do that, it has to use another algorithm called a gradient descent. Okay, so gradient descent allows the model to find the best weights. So in this video, I'm just introducing to you terms. Maybe you had forgotten, or maybe it's your first time, but now you're being conversant with some of the terms we use in machine learning for you now to be able to approach learning machine learning better in this case. Okay, so what is gradient descent, or how does gradient descent work? So normally it starts with random weights, and then they make predictions using the current weights. Okay, then we calculate how wrong the predictions are based on the MSC, the cost function, and then we nudge the weights slightly in the direction that reduces the error. So in this case, the values with more importance are sort of nudged positively, and then hopefully that reduces the error at the end. So we repeat this until the error stops improving. Then after training, the weights tell us which feature matters most. A high weight on the word, for example, painful, would mean that that word is a strong predictor of high side effect severity. Okay, so in essence, that's what we've covered. We've covered linear regression. As simple as that. Again, we haven't dived deep into the mathematics, but just an overview of what is involved. So just a recap, over here we've captured linear regression. We've talked about how it is used to predict numeric values, like for example, estimating blood pressure. We've looked at the mathematical formula. We've said it comes from the basic linear algebra equation of y is equals to mx plus b. We've seen how it variates here when we bring in the aspect of machine learning model, where now we incorporate the weights, the weight term, and then we've seen now what the model learns is basically it wants to reduce the cost function. And in our case, the cost function will be the mean squared error. Okay. Then we go further, and then we say for us to minimize the cost function, the model uses gradient descent to adjust the weights or to update the weights. So the model uses gradient descent, updates the weights, this weight reduces the cost function, and that's how we get closer to a good model which pays attention to which features matter most. As simple as that. All right, great. So that is linear regression, a high overview. I hope you've gotten a word or two. Let's move to the next one, which will be logistic regression. So if you still enjoy this kind of videos, like, subscribe, and catch us on logistic regression.